Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/today. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel with practice problems is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible, at least to the extent allowed by law, donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam FM on financial mathematics. The annual force of interest credited to a savings account is defined by delta sub t equal to t squared over 100 divided by 3 plus t cubed over 150, with t in years. Austin deposits 500 into this account at time 0. Calculate the time in years it will take for the fund to be worth 2,000. And here's the solution. The initial deposit was 500, so over time that is needed to get to 2,000, the accumulation function has to go from the initial value of 1 at time 0 to a value of 4 at time t, so a of t has to be 4. So we're going to find the formula for the accumulation function, and then we'll figure out when it's equal to 4. Well, a of t is e to the integral from 0 to t of the force of interest that we are given, and because we're integrating from 0 to t, we'll use a variable s for the force, for the time that the force depends on. S is the time, and s varies from 0 to t, so it's the integral from 0 to t of s squared over 100 divided by 3 plus s cubed over 150 ds. And we note that if you take the derivative of 3 plus s cubed over 150, that derivative is equal to what? 3s squared over 150, and that 3 has a common factor of 3 with 150, so that's the same as s squared over 50. But if you multiply that 50 by 2, you get what you see there as s squared over 100. So this s squared over 100 can be written as 1/2 of the differential of 3 plus s cubed over 150. So what we see here is a logarithmic derivative of 3 plus s cubed over 150 multiplied by 2, by 1/2, by 1/2 effectively. So the integral of this is 1/2 ln of 3 plus s cubed over 150, and we evaluate it from s equal to 0 to s equal to t, and that becomes half of ln of 3 plus t cubed over 150 minus 1/2 ln of 3. And then that 1/2 can be made into the exponent of the expression that follows the natural logarithm, so that basically says that we have natural logarithm of a square root of 3 plus t cubed over 150 minus natural logarithm of the square root of 3. Of course, difference of logarithms is the logarithm of a ratio, so this becomes e to the ln of square root of 3 plus t cubed over 150 over 3. And then if we divide the top and the bottom of this fraction by 3, that fraction under the square root sign simply becomes 1 plus t cubed over 450, and e to the natural logarithm, well, these are the inverse functions of each other, so this whole expression is simply square root of 1 plus t cubed over 450. And we want this a of t, which is the square root of 1 plus t cubed over 450, to be equal to 4. Well, then we solve this as an equation in terms of t, and t is equal to, well, when you take the square of both sides, it will be 16 is equal to 1 plus t cubed over 450, and 16 minus 1 is equal to t cubed over 450, so that t is equal to 16 minus 1 times 450 to the 1/3. That's approximately 18.898816, which is answer E. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on